by our microcontroller to determine which kind of solution should be going into the cells. And then the receiving solution over here, after we finish the extraction, will be flushed into the HPLC injector for the sample injections. And after the injection, the HPLC pump, the pumping the mobile phase will go through the samples into the CAD column for separation, and finally directly go to ESI, electrospray mass spectrometry, for quantification and identifications. So this is our systems. We have the IIS waters container for cleaning and rinsing purpose. We have a waste container to collect all the waste for cleaning and etc. Sample and acceptor solution is all placed in here, or you can just simply connect the tube to any other sample source for sample suctions. A high voltage power supply, which is actually directly connected to the cell, and the cells actually is pretty small over here. And we have a current profile recording system to record the total current generated by the ion migration during the extractions. So this is how basically we couple with the LCMS. The extraction module is on the top. This is a benchtop LCQ Dakar ion trap mass spec. So you can see there is a tube over here that directly going into the injector here, which is actually we flow through the acceptor solution into the sample injector, and this is actually our Lacrom LC systems. And look at this more controller box, which we built ourselves. It's actually contains an Arduino microcontrollers chip port, which is connect directly from USB to your laptop. So we need to write a program, which is basically a program language C, which is quite famous among the software engineer. And then everything inside this box is controlling the pump, the selection valve, when you are going to apply the voltage, when you turn on the switching or sample switching for the injection valve. But for the mass specs, you normally use mass specs software to analyze the samples. So this is actually the software that we developed. I'm not sure. Yes, it's very easy to actually automate experiment procedure. Because right now the technology is so advanced, I have no idea what is this before, but it's so simple that you can control using a USB from your laptop, and then using a small controller box to control any instruments that you would like. So we can see that we program into, you probably can see very clear here, your system initialization, stream cleanings, injecting sample solutions, flushing the chamber, and perform complete extraction procedure. So what we do is just key in the number over here. You can key in any number that you want, and then the entire procedure in the system will perform automatically. So you're also able to perform analysis for multiple analysis by keying total number of analysis that you want to perform. So this makes our analytical chemist life very easy right now by having the automated procedures. And this is the summarized comandograms for the mass specs, showing that the PCA herbicide enriched in the acceptor phase on extractions of blank river water samples. So there is no PCA herbicide detected after extractions. For sample B, it only contains 0.2 microgram per liter, which is ppb. This is very low already, but for EU requirements, you need at least 0.1 ppb as the detection limit. So it should be fine because we can actually achieve even much lower, but this is for demonstrations. So the sample volume is 5 ml, acceptance volume is 40 microliter, and the flow rate is only 0.2 milliliter per minute into our microfluidic cells. The applied voltage 200 volts. Okay, so that's round up my presentation today, and this is my collaborators. University Hospital Basel, IIS Swiss Battery Institute of Aquatic Science and Technology, EDEC company that we are is actually selling one of the products that produced by our PRC Hauser, which is the contactless conductivity detections, and also UTM for sure, and two financial supports from Swiss National Science Foundation as well as from the UTM. And Pierre Hauser is actually our group's leader. That's he's actually not working with extraction at all. He's working with contactless conductivity detections on the microchip as well as capillary electrophoresis. So I'm the only one that developing these brand new techniques in the groups. So I have 3 very lovely master students. And Lucia is actually working with me on another project which is focusing on the non-aqueous capillary electrophoresis, but I'm not going to cover that today, maybe the next seminars soon. And there's other colleagues that working on contactless conductivity detections, and there are also several others PhD students which is not present over here. Okay, so the interesting parts about Switzerland. So I've been staying there for 3 years. So please allow me to spend a little bit of the time to show you some of the things about in Switzerland. I'm living in Basel, which is at the border of France and Germany. So we can actually walk across Basel to France and Germany if you feel free to. So in Basel, you know chocolates, or Switzerland is famous, and also the Swiss watches, this everyone know. And this is actually a bear, which is represent the capital Bern, but it's made from cheese. So Swiss people like cheese a lot. There are 100 kinds of cheese in the supermarkets for you to choose. And you have to know Roger Federer because for me, in Basel, you have to know because he's from Basel and his house is very close to my house because Basel is very small. And this is a very special ice cream from Switzerland, which is comparable with Haagen-Dazs ice cream that well known in the world. But last few weeks I saw this one in somewhere in JB, but I couldn't remember. So this is pretty nice, and you have to know how to ski. I was forced to go to the ski school to learn how to ski because the entire group is going for a skiing trip. So I went to the adult school for a ski course for a few days. And Basel, this is our department. It's actually a normal building in the middle of the streets. So you won't even notice that it's actually a physical, inorganic and organic chemistry inside. You probably know Novartis and Roche, 2 of the biggest pharmaceutical companies that have the main campus in Basel. So we have a lot of research actually going on together with these 2 companies. This is some kinds of like private fundings that we are actually looking for here. But in Basel, they receive a lot of funding from this kind of pharmaceutical company. And this is our very famous landscape, the city hall, which is called Rathaus, which means the red house in English. So it's in the city centers of the Basel. And this is the Cathedral Church, which is another landscape. And this is the ancient city gates of Basel, because Basel is surrounded by the a wall, actually a wall, but this is the gates of the wall. But now the wall is no longer there, and only the gate is present. It's actually maybe 19, so it's about 1,000 years old, more maybe, because I remember it's somewhere 1800 somethings. And I'm actually living opposite of this gate. So every morning I'm listening to the clock of this gate to wake up to work. And we have a very important river, it's Rhine River, and this is a special wooden ferry that powered only by the river current to send you across the river. So normally the tourists will try this one, but I only tried this one before I'm back to Malaysia, because my friend said you should try this once. So this is the Rhine River. This is very important for me because I spend a lot of times during evening in the summer sitting around the river, just spending time with friends, doing barbecue, and just relaxing, because the entertainment in Basel is not that much compared in Malaysia. So everything is a bit quiet there. This is Tunze. So as I mentioned, sea is lake. So this is what we call the Tun Lake in Lucerne. So it's a very famous place for the tourists. You can see the Alps is actually at the back over here, this entire Alps. So actually we went for hiking, and we climb all the way up, and then take a pictures, and then we go down. I think we take a train, or a cable car somewhere. Cable car go down. And this is Schwarzsee, another lake. In Switzerland, we don't have any sea surrounding, so the lake is become our main source of seafoods, basically. And last but not least, Matterhorn. So this is the most famous landscape in Basel for me. You probably know about this chocolate, but you never know, or probably don't know why the shape is like this, why the logo here is like this. But it's actually these mountains are located in Zermatt, which is very close to the Italy regions. So this is not the best chocolates, I would say, but this is just very famous because of the shape of the Matterhorn and also the shape of the chocolates. Okay, so thank you very much for your attention. This is a very special stamp that's produced by the Post Office of Basel when the university is celebrating 550 years old. So the university is one of the oldest university in entire Switzerland until present. So thank you once again for your patience and your kind attention. Yes, sir, I welcome, sir, for any questions about the research, or you have any curiosity about Switzerland, so you feel free to ask anything. Yes.
Yeah, if you have any questions, go to our policy about his research, about Switzerland, about chocolate. Research.
I saw some students, but actually Switzerland's Swiss National Science Foundation is providing quite lots of opportunity for students to go there for postdocs and also for PhD programs. So if you have an interest to go after finishing your undergrad, no undergrads, but the postgrads, you can send me an email. I can send you some info. Yeah, correct. So it's very nice. Yes.
Thank you so much for your very nice interesting presentation. Actually, I'm from the MTech in UTM. So I would like to know your membrane fabrication. Is it the membrane, commercial, or you fabricate in the industry?
No, it's not commercialized, the membranes. You mean the membrane, is it commercialized already?
I mean the hollow fiber membrane you mentioned at the beginning.
Oh, no, we prepare ourselves. Or everything in the labs.
That's right. So, about the reproducibility of the membrane,
Yeah, definitely we try to produce the results by preparing a series of same membranes for our extractions. And so I show some of the results. Basically, the result is very promising because for most of the data that we reported so far, you see we have an RSD. RSD is the relative standard deviation that we try to determine when we're trying up to 3, sometimes 5 replicates of the identical extractions. So normally we never achieve more than 10%. Which is very good. Some of the experiments we only achieve below 5%, it depending on your sample matrices.
That's right, thank you so much. About the chamber, the UV chamber you showed to us, I think it was number 5, number V.
Sorry, chamber? UV chambers. You mean
yes.
This one? Okay.
That's right. You mentioned about the UV detection at the top, right side.
Yeah.
So it means the UV was inside the chamber?
No, you just connect a tube to flow through the UV. Okay, I know what you mean. This is not a normal UV spectrophotometer. This is a special UV for capillary electrophoresis. So what you need to do is you just burn a window at the capillary, put it in, and the sample solutions will flow inside the capillary, and the detection is actually contactless, which means you do online.
Okay.
Yeah, so this UV, that's right, that's true, a very good question. This is not a very normal UV detector. This is for the design for the capillary electrophoresis. Yeah.
Thank you so much for your answers.
Thank you very much. Okay, this is very good questions. The first things, normally I will show you one of the examples. Okay. Right now, there are 2 major approaches in our research focus. Is the first thing, we still don't know how the ion migrate across the membrane. That's the main issue. We need to perform, for example, to determine the conductivity, to see how actually the ion is migrate across the membrane itself. At the moment, we can't explain why. It could be due to the electrokinetic migrations, or it could due to the ion exchange process, or maybe the ions when passing through the membrane itself is actually hopping across, which means when the ion going through over here to here, we don't know whether it's jumping because we have carrier as the mediator, so the ion is hopping from the one mediator to another one, or it's just a very simple electrokinetic migrations. That one we pretty not sure. As for the conductivity of the membrane, we actually try to plot a very simple Ohm's law graph to see the resistance of the membrane, but the resistance of the membrane changes according to your applied voltage. So that creates even more questions to the membrane properties. Maybe we can work together on this one later on to find out. Yeah, exactly, that's right. Because normally we focus on what we think we are excellent in, and we always are hoping to collaborate with other groups to solve some of our problems and the mystery about these mechanisms. Okay, thank you very much.
Okay, thank you for the C for the very good talk on the new design electric wheel-driven inclusion membrane. And he has also shared with us his very wonderful experience in Switzerland. Okay, now I want to invite Director of IIS Institute, Professor Dr. Mustafa Samsuddin, to present the certificate of appreciation to Dr. C. Thank you for his very enlightened talk today. Yeah. Okay, please. Okay, thank you to Dr. C again, and thank you for your kind attention. We'll see you again in the next seminar. So all are invited for the very brief refreshment at the next door. Thank you. Next door. Yeah.
Kita boleh tanya. Kita tahu bisa ganti.
Ya.